Okay, we're recording now. Let's see, something's not right. Okay, let me try that again. Okay, I think we're good. All right, so schedule today, 2.2. Then I'll give you your second quiz. So the quiz will work just like last week. Okay, so I'll put you into your breakout rooms. It's up to you if you want to show your camera or not during the quiz. To me, it's a little bit weird that you can't see everybody during the quiz, but that's up to you. Okay. So again, the only time I absolutely positively insisted you have your camera on with the natural background is during exams. So for next Thursday's exam, that would be the case. I'll talk more about the exam next week. Okay. And so again, I'll give you a question or two or three or whatever, put you in your breakout rooms. You'll have a group of either 3 or 4. And then most of the time I'll be in the main room. Star will be around to go to different rooms as necessary. And then your object is to get it right and get everybody else and get your teammates to get it right also. You can put your first and last name and everybody else's first and last name. If you don't do it this time, I might take off points for that because you're making more work for me to find out who is on your team. Okay, so you work it out, you get it right, get everybody else in your team to get it right. And then you have until our normal ending time of 1 o'clock. You'll probably finish way before that. And then just get your cell phone, click, 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 or if you have a scanner, scan it, email it to me, and then that's it. Okay, and then I will look at all the quizzes to make sure, you know, it's different handwriting and all that stuff. I will grade only one person's quiz from your team, and whatever the grade it is, everybody gets the same grade. Okay, so you don't know who I'm going to pick. So obviously, the only way to be sure that you get full credit is to make sure everybody in your team gets it right. Then, of course, it doesn't matter who I pick. Then you're all going to be good. Okay, and then over the weekend, I'll email you your score. Okay, I will probably just reply back with something like 5 out of 5, 4 out of 5, 3 out of 5, 2 out of 5, and so on. It's not really that hard to get 5 out of 5 because you talk about it, open book, open note, open discussion, help each other out. Okay, so last time almost everybody got 5 out of 5, and I'm anticipating the same thing today. I mean, it's pretty easy, right? Since you get to help each other out. But again, once you get it right, don't leave. Make sure everybody else in your team gets it right also. Okay? So that's what's happening for today. So any questions about that? You can put it. You can go ahead and put stuff in the chat. I can't see it again, but go ahead. You're welcome to put stuff in the chat, and maybe Star can answer it if necessary. But if not, we'll just go on. Okay. So 2.2. Okay. Last time we did the quadratic formula. We're doing more variations of it, and this is page 102. It's yellow right now. Let's switch it over. Okay. So let me look at our assigned list again. 15 to 57 and 61 to 75. Okay, so let me show that to you for those of you who don't plan to get the book. Okay, 15 to 35-ish. Well, what are the questions? Find all real solutions of each equation, right? Never mind about the decimal approximation. Okay, you can do that or not. I'm just focusing on getting the exact answer, so-called, which might involve a radical. Okay, so never mind about the decimal approximation. Okay, then here's some more. And I hope you can see that. Okay, that's up to 57. Then let's see, what else we have? 61 to 75. 61 to 75, so radical equations, right? So there. And there's 75. And I think that's pretty much about it. Okay. So here we go. Solve equations. First one was 15. So why don't I just show you 15? (2.215) 3x squared minus 48x equals 0. (3x squared minus 48x equals 0. Okay. You could use a quadratic formula, but it's a lot easier to just factor. So let me factor out the common factor. So 3 and 48 are both divisible by 3, and there's a common factor of x. So I'll factor out a 3x. Okay, and this would be x minus 3 times 16, or 48 divided by 3 is 16. So 3x, x minus 16 equals 0. Let's double check. You can always double check by distributing 3x squared minus 48x. Okay, so by the zero factor property, either this is 0 or this is 0. In other words, 3x equals 0, 3x equals 0, or x minus 16 equals 0. But usually this is a pretty easy step. Okay, so if you don't want to write this, this is optional. If you want to go straight to the answer, that's okay. What makes this expression 0? 0. And what makes this 0? 16. So x is either 0 or 16. Okay, so that's pretty much about it. Okay. All right, and I was going to show you 17. T cubed minus 125 equals 0. Now, in the directions, it only asks for the real solutions. Okay, we can find complex solutions later, but for real solutions, it's actually much easier. All right, so there's a cube here. To get rid of a cube, we want to do a cube root. So first I'm going to move the 125 over. Okay, again, I trust you know that means add 125 to both sides, right? You've seen that before in Algebra 1, Algebra 2. T cubed equals 125. Okay, and now the question is, how do I get rid of a cube? You need to do a cube root. That means you go like this. Okay, so the cube root of t cubed, they cancel out, so you mean just t. And then the cube root of 125, it's not that hard, especially since it ends with a 5. Can you guess? 5. 5 cubed, 5 times 5 times 5 is 125. So t is equal to 5. So that's all. Okay. Okay, now some more complicated ones here. I think I'll try something like 25. A little bit more complicated. X to the fourth minus x squared equals 6. X to the fourth minus x squared equals 6. Okay, this is actually a quadratic. Okay, you can think of x to the fourth as x squared squared, right? Okay, so yeah, I'm going to move the 6 over. I'm going to write x to the fourth like this. X squared squared minus x squared minus 6 equals 0. I'm even going to put parentheses around this. Okay, this x squared is the same as this x squared. So, I mean, just pretend it's a single letter, like y. In fact, one way to do it is just pretend this is y. Temporarily call this y, right? Y squared minus y minus 6 equals 0. You say, oh yeah, that looks like something I can factor. Okay, so one more time. When this is x to the fourth and this is x squared squared is x to the fourth. So I'm going to write it like so. Temporarily call this y squared minus y minus 6 equals 0. Okay, so that looks like something familiar. So y. Okay, how do you get a product of 6 and a difference of 1, 2, and 3? And you want to end up with a negative. That means the negative should go with the larger number, like that. So y plus 2, y minus 3 equals 0. Now I'm going to switch y back to what it was. What was y originally? X squared. So I'm going to change that to x squared. And change that to x squared, because that's what it was originally anyway, right? So x squared plus 2, x squared minus 3 equals 0. Okay, and let me uncurl the paper. Paper tends to curl on me as I go along. Okay, so I temporarily made a substitution to make it look nicer. And you say, what's this x squared stuff? If you temporarily call it y, so oh yeah, that's a y. I can factor that and go from here. Now, very, very technically, you could have gone straight from here to here. And if you're slick enough to do that, if you can recognize that you can go straight from here to here, I'll let you. Maybe I'll just draw an arrow, meaning I'll let you go from here, or actually from here to here, sorry. From here to here. All right, so by the zero factor property, either this is 0 or this is 0. X squared plus 2 equals 0, or x squared minus 3 equals 0. Move over to 2, move over to 3. X squared equals negative 2, or x squared equals 3. Okay. Now, in the directions, up here it says find all real solutions. So none of the imaginary stuff, none of the I stuff. So this one can't happen. If it could, I'd go back to I. We'll do a lot more I stuff later. But for now, for real solutions, I only do this. Okay, so I do the square root property, square root, plus or minus, x equals plus or minus radical 3. Okay, and you can stop there. Just leave it alone. Okay. I'll show you another one like that. Let's see. I'm going to do 29, which is sort of similar. Three t squared plus 2 equals 9t to the 4th. All right, so this one, I might not be willing to do the whole thing, but at least I'll set you up. Let me subtract this over. Negative 9t to the 4th plus 3t squared plus 2 equals 0. Okay, now, I dislike having a leading coefficient be negative so much. I'm going to multiply both sides by negative 1, just in order to get this to be positive. Yes, that will change this to be a negative. This will also be a negative. That's still preferred. Okay? Even though there's only one negative here, and the thing I'm going to come out with has two negatives, it's much better to have the leading coefficient positive when you're using quadratic formula, factoring, or whatever. Okay, so 9t to the 4th plus 3t squared, sorry, minus 2 equals 0. Okay, so this is preferred. All right, now, just like the previous one, this can be thought of as t squared squared. It's almost like the variable is t squared. Okay, so I could factor with the variable being t squared. In other words, this problem is right now just like this problem. Okay, it's almost like the variable is x squared. Now, I can try to factor this. I'm not sure if this is factorable or not, okay, with the variable being like t squared, okay, but I can always use the quadratic formula. Okay, and I want to show you with the quadratic formula anyway, since I've done factoring now. So factoring is fine. Okay, so I'll use the quadratic formula with a, b, and c being 9, -3, and -2. but my variable, quote unquote, is t squared. And then, of course, after that, I would take the square root on top of that. Okay, so again, I'm going to use the quadratic formula with t squared functioning as a variable. I mean, if this had been 9x squared minus 3x minus 2, you would say, oh, yeah, quadratic formula. Okay, so it's like the variable is t squared. Okay, so I'm going to come up here. The A was 9, B is negative 3, C is negative 2, 9, negative 3, and negative 2. Okay, so t squared. All right, so quadratic formula, negative b is a positive 3, plus or minus the square root of b squared, negative 3 squared is 9, minus 4 times a, which is 9, times c, which is negative 2, over 2 times a, 2 times 9. Okay, and mind you, this is t squared, not just t. All right, this is another double negative case. So you know what I like to do with double negatives? Make them positive, right? Positive, positive. Okay, 4 times 9 is 36. 36 times 2 is 72. So scratch paper, 9 plus 72 is 81. That's very nice. 3 plus or minus the square root of 81 over 18. Square root of 81 is 9. Okay, so it looks like I'm going to get it. Okay, mind you, I'm doing t squared now. T squared, if I do the negative, 3 minus 9 is a negative 6. Negative 6 over 18, which reduces to negative 1/3. And yeah, just like the previous problem, for real numbers, that can't happen. Yes, for imaginary numbers, it works, but not for real numbers. And then we do the positive. 3 plus 9 is 12. 12 over 18 reduces to 2/3. That can be done, right? That's t squared. Do the square root property, right? So t is plus or minus square root of 2/3. Okay, then I'm going to rationalize the denominator. Remember to rationalize the denominator. Multiply top and bottom by radical 3. Okay, because the square root of 3 times another square root of 3 is just regular 3. Okay, and that'll be radical 6, it looks like. So plus or minus radical 6 over 3, and we're done. Okay. All right, so that's it for that one. Okay, I was going to show you 33 next. X plus 4 to the 5th power plus 16 equals 0. Solve for x. Okay, I'll move out to 16. Negative 16. Now, if you're writing this down and you're trying to do exactly what I'm doing, leave yourself a space here. Need a little gap. Whoops, I forgot to find. Okay, there's a 5 here. So we know when you have a square, you do a square root. Cube root. So how about a 5? 5th root. Like that. 5th root. That 5 cancels out that 5. Okay. Can I take the 5th root of a negative. And one way to think of it is, what's a negative raised to the 5th power? Negative times negative times negative times negative times negative. Every time you have 2 negatives, they cancel out, but you have 1 left over. So that's going to be okay. So this is fine. It's not a nice number. So what's the 5th root of negative 16? I don't know. You can use a calculator for it, but we don't really care about that. But main thing is that it exists. It is a real number. Okay, so just move the 4 over, and then we're done. So x is negative 4 plus the 5th root of negative 16. And yeah, just leave it like that. Okay, and actually I was just looking at the problems. 75 is a little bit more complicated than I wanted. So I'm going to throw out 75. Okay, let me look at our assignment list. So we're going to stop at 73. Make it 73, please. Okay, so 2.2. It was originally 61 to 75. 75 is a little bit harder than I want it to be, so we'll stop at 73. Okay, next type of problems are these. Okay, so they got other weird stuff here. Sometimes more complicated. Okay, so how about I show you 43. X to the 6 plus 7x cubed equals 8. Okay. X to the 6 plus 7x cubed equals 8. All right, I want this side to be 0. Move that over. And once again, this is x cubed. This is x to the 6. This exponent is exactly twice as big as this. So I'm going to pretend this is x cubed squared. Plus 7x cubed minus 8 equals 0, like that. Right? X cubed squared is that, x to the 6. Just like over here. So I can make a substitution, change this to y, or whatever. Or I could do the quadratic formula. Okay. But I'm going to go straight to factoring. I know this one factors. Okay. Which means go straight to x cubed, like that. Because I know x cubed times x cubed is x to the 6th, which this is. Then I get some combination of x cubed and then an 8. Okay, so I see a 7 and a negative 8. So what two numbers have a difference of 7 and a product of 8? That means when you multiply them together, you get 8. When you subtract, you get 7. Well, 1 and 8. And you want to end up with a positive. If you want to end up with a positive, positive goes with the larger number. That's how it factors. Double check. Multiply it out. FOIL. That times that, x to the 6. Outer, 8x cubed. Inner, minus x cubed. That's 7x cubed. And there's your minus 8. Okay. So it definitely works. Good. Okay, so now by the 0 factor property, if something times something equals 0, that means either this is 0 or this is 0. X cubed minus 1 equals 0, or x cubed plus 8 equals 0. Okay, so to get rid of the cube, you have to do a cube root, right, which we've already done over here. Okay, so move over the 1, move over the 8. X cubed equals 1. I'm leaving a gap. If you're trying to copy what I'm doing, leave a gap. X cubed equals, leave a gap, negative 8. Raise it up again. Try to get rid of that yellow. Okay, how do you get rid of the cube? Cube root. Cube root. Cube root. Cube root. Cube root. So cube root of 1 is 1. Cube root of -8, what number times itself gives you -8, -2. So there we go. Okay, then we have some other really weird problems, but it's sort of the same style. Like 45 and 47 and 49, they got these weird negative exponents. Okay, so let me try to tackle the negative exponents for you. 45, 47, 49. 49 looks the worst, so I'll do the worst one. That means you get to do the easier ones. Okay, so let me try 49 for you, okay? I know you can't see it yet, but I have to write it first. 4x to the minus 4. Minus 33x to the -2. Minus 27 equals 0. That's a -2. That's a -4. That means this is x to the -2 squared. Right? X to the -2 squared, x to the -4. This one is so weird and so complicated. Let me go ahead with this technique of making a substitution. Okay? So I'm going to temporarily call this, let's say, y. So y equals x to the -2, which incidentally means 1 over x squared. I'm going to need that later. That way I have an easier equation. 4y squared minus 33y minus 27 equals 0. Okay, I can tackle that, right? So 4y squared minus 33y minus 27 equals 0. Okay, much nicer rather than having this x to the -2 stuff. Okay. All right, does it factor or does it not factor? I'm not sure. You can always use the quadratic formula, though. So why don't I use the quadratic formula? Okay. The quadratic formula, remember, always works, whether the original was factorable or not factorable. Now, this one I could tell right away it's factorable. This one I cannot tell right away, but no harm if it's factorable. Quadratic formula gives it to me anyway. So let's just go with it. So my A, B, and C are 4, -33, and -27. Okay, so -b, 33, plus or minus the square root of b squared. Oh boy. -33 squared is the same as 33 squared. 33 squared. 1089 b squared minus 4 times a times c. 4 times 4 times -27. All over 2a, 2 times 4. Okay, so calculator time. Again, a double negative, right? What happens when you have a double negative? Negative positive. Okay, so let me just get my calculator out and figure this thing out. So 1089 plus 4 times 4 times 27. 1521. 33 plus or minus the square root of 1521 all over 2 times 4 is 8. Hit the square root button, and square root of 1521 is 39. Very convenient. Okay, so 33 minus 39 is negative 6. Negative 6 over 8, which reduces to negative 3/4. And if I do the plus, I get 72 over 8, which equals 9. Okay. Unfortunately, we're not done. That's why y is equal to 1 over x squared. So if I change that to 1 over x squared, change that to 1 over x squared. So 1 over x squared equals negative 3/4, or 1 over x squared equals 9. Because that was y. Okay, I can take the reciprocal of both sides. Okay, you may not have heard that before, but you can reciprocate. Flip this, flip this. See, I don't want 1 over x squared, I just want x squared. Okay, so off to the side, if 1 over a equals 1 over b, then a equals b. Okay, which means flip them. Flip this, flip this. X squared equals negative 4/3, or x squared equals 1/9. By the way, another way, if you're not convinced of that, you can cross multiply. Remember the cross multiply rule? If you cross multiply here, you get negative 3x squared equals 4. And if you do that here, you also get 3x squared equals negative 4. Same thing. Okay? If you cross multiply here, you get 9x squared equals 1. And this one is also 9x squared equals 1. Okay. All right. This can't happen for real numbers, so cross that out. This one, do the square root property. Square root, plus or minus. X equals plus or minus 1/3, like that. Okay. All right. Okay, then just one more like that before I go to the radicals at the end. 51. Okay, so I would have shown you this, and then there are radical equations after that, so let me do some radical equations also. 51, t to the 2/3 equals 9. T to the 2/3 equals 9. Well, let me write that as a radical. Squared goes here, 3 goes here, equals 9. Okay, so power root. Remember, the power is on top of a fraction. The root is on the bottom. When you have a fractional exponent like this, power over root. Okay. How do I get rid of the 3? You cube both sides. Cube. Okay. 9 times 9 times 9, you can use your calculator. 729. Now I just do the square root, right? Square root. Square root. For square root, you need plus or minus. Okay, you can punch it in the calculator. Square root of 729 is 27. So t equals plus or minus 27. All right, I'm done with, whoops, I'm done with equations of this type. Where to go? Here. So 61 to 73, there are now radical types. Solve equations with radicals. Okay, so let me show you that. I think I'm just going to keep going like I did last time. Okay, ordinarily this would be a good place to break, but I figured out if you just let me go a little bit longer, I'll be done, give you the quiz, and then go from there. Okay, so let me just go on, if you don't mind. It will be past 12, but that's going to be it. Okay, so on a regular day, I would stop, break, but since I only have a little bit more, I'll go past 12, and then you can break or not as you're doing the quiz, okay? So let me do it that way instead. Okay, solve equations with radicals. Okay, check your answers to eliminate any extraneous solutions. Okay, for these problems, it turns out some of them just don't work, not because you did any algebra wrong. It's just they work, they don't work. Okay, so for radical equations, you must go back and double check your answer. Okay, so I'll show you how to do that. Okay, 61, square root of 1 minus 3x equals 2. Okay, how do you get rid of the square root? You square, right? Square. So when you square a square root comes off. 2 squared is 4. And look at how easy that is, right? Okay, subtract 1. Divide by negative 3. X equals negative 1. Check. By the way, it's never wrong to check. Okay, and I'm being a little bit hypocritical because I haven't been checking a lot of my answers, but it's to save time. But if you have plenty of time on an exam, let's say, you say, I wonder if I got the right answer. Plug it in, see if it works. Okay, so plug negative 1 back in the original. Square root of 1 minus 3 times negative 1 equals 2. I'll put a question mark, meaning I don't know if it's true. I'm checking it. Double negative, that's 1 plus 3, right? So 1 plus 3 is 4. Square root of 4 is equal to 2. That does check. So I keep my solution. If this answer did not check, I would throw it out and I would say no solution. Nothing actually works. Okay. All right, that was a fairly easy one. Let me do a harder one for you. Let's try something like 67. Okay. Again, these problems are right off the homework. So each one I'm doing is one less you have to do. 4x plus square root of 2x plus 5 equals 0. All right, before I work this out, I should move one or the other goes on the other side. You don't want to square as is. If you square like this, it'll be a mess. You have to do that a squared plus 2ab plus b squared thing, okay? And you don't have to write down what I said. It's more complicated. So just move one of them over. How about I move this one over? So now it looks like that, right? Now I can square both sides. Okay. Square, square. Very conveniently, that minus gets lost, right? Because a negative times a negative is a positive. 2x plus 5 equals 16x squared. Move the 16x squared over. Negative 16x squared plus 2x plus 5 equals 0. And yeah, as I've mentioned before, I really don't like the leading coefficient to be negative. You shouldn't either. Okay. So multiply both sides by negative 1 to make it nicer. 16x squared minus 2x minus 5 equals 0. Okay, once again, you have a choice. Factor or quadratic formula? Okay. Factoring, you might get stuck. Quadratic formula, you're never stuck. Okay, let's do quadratic formula. Okay, negative b, negative, negative 2. Plus or minus, square root. B squared. Remember, if you forget the quadratic formula, put it on your cheat sheet. You're allowed to for next Thursday's test. Okay, b squared, negative 2 squared is 4, minus 4 times a, 16, times c, which is negative 5, all over 2a, 2 times 16. And what's it going to have a double negative? Which will be a positive. Okay, so let me punch that out on my calculator. 4 plus 4 times 16 times 5, 324. 2 times 16 is 32. And square root of 324 is 18. Over 32. All right, so here we go. So 2 minus 18 is a negative 16 over 32 is the same as negative 1/2. And 2 plus 18 is 20. 20 over 32, which reduces to what? Let's see, I can divide it to 4, right? So if I divide it to 4, 5 over 8. Let's check though. Actually, I can tell right away 5 over 8 is not going to work. Okay. Can you look back at the original? If I plug in 5 over 8, that's positive, you're not going to get 0. Okay. So let me get that one out of the way right away. 4 times 5/8 plus square root of 2 times 5/8 plus 5 for sure is not 0. I don't even have to compute this, right? The logic is this is positive, plus these are all positives, add a positive, square root of a positive is positive. You're going to get a positive number. It isn't 0. Okay, so 5/8 is definitely out. Okay. Now what about negative 1/2? Now if negative 1/2 doesn't work, I would say no solution. So let's see if it works. So what am I plugging in? Negative 1/2. Okay, so 4 times negative 1/2 plus square root of 2 times negative 1/2 plus 5 equals 0, question mark. Is it or is it not true? So let's see. 4 times negative 1/2, negative 2. 2 times negative 1/2 is negative 1. I'll raise it up. Again, I'll raise this up again if you want to look at the video later for better focusing. Okay, that is 4. It works. Negative 2 plus 2 equals 0. That checks. Raise it up again for focusing. That's a question mark. That's a question mark. Okay. Question mark means I don't know it's true. I'm trying to see if it's true. Okay, so the only real solution I'm keeping is x equals negative 1/2. Okay. Okay, so I only have a couple more to do. So let me just do these last ones and knock it off. Yes, it'll be a little bit past 12, but I think it'll save time in the long run. Just bear with me a little bit longer. I'm done. I'll give you the quiz, and that's it. Okay. Okay, how do you do 69? square root of, oh boy, x to the fourth minus 13x squared plus 37 equals 1. Okay, well, square both sides. This one just drop off the radical. One squared is 1. Move the 1 over. That'll become 36, right? Aha. X to the fourth, x squared. So I could do the substitution game like I did for the other ones. And this one I think is pretty easy to factor. So I'm going to go x squared. A minus and a plus, you might recall, are both minuses. And then I don't think this is that hard. 13 and 36. Can you think of two numbers so that the product is 36? When you multiply them, you get 36. The sum, when you add them up, you get 13. 4 and 9. Okay. And these, you could do the square root property, but I think it's easier to factor. These are both differences of squares. X plus 2, x minus 2, x plus 3, x minus 3. So either this one is 0, this one is 0, this one is 0, or this one is 0. Okay. That's going to be negative 2, positive 2, negative 3, positive 3. Let me write it like this. X is plus or minus 2 or plus or minus 3. Okay. And let's check. Now, at first glance, you might say, oh man, I got to plug in 4 numbers, negative 2, positive 2, negative 3, positive 3. I'm actually going to plug in this whole thing plus or minus 2 and then plus or minus 3 because if you look back at the original, when I raise something to the 4th power or the 2nd power, it doesn't matter if I put in a plus or minus, you're going to get the same thing over. Okay, so that means they're both going to work or they're both not going to work. So that makes it a little bit easier. So x is plus or minus 2. So it doesn't matter if I put either a positive or negative 2. I will plug in plus or minus 2 to the 4th power minus 13 plus or minus 2 squared plus 37. Is that equal to 1? Okay. Either a negative 2 or a positive 2 to the 4th power is 16. Okay, that's going to be either a negative 2 or a positive 2 squared is 4. So negative 13 times 4 is a minus 52 plus 37. Is that equal to 1? This comes out to be 1. Square root of 1 equals 1. Yes, it does check. And do the same thing for plus or minus 3. So way back in the original, put plus or minus 3. Looks like it's a little bit harder. Plus or minus 3 to the 4th power minus 13 plus or minus 3 squared plus 37. Is that equal to 1? Okay. I know it looks funny to plug in plus or minus 3. Normally you can't do that, but in this case you can because I'm noticing I'm only raising to the 4th power and the 2nd power or square it, and that means in either case I get the same thing. Okay, so it's not going to matter. Okay, either positive 3 or negative 3 to the fourth power is 81. Either positive or negative 3 squared is 9. So negative 13 times 9, punch it in your calculator, is negative 117 plus 37. Is that equal to 1? And if you punch it in your calculator, it does work. Square root of 1 equals 1. So they all work. So I keep all my solutions plus or minus 2, plus or minus 3. Okay, folks, I'm down to the last one. Then I'll give you the quiz. Okay, but don't get your hopes up too high. This last one is the hardest of them all. Okay, so it is the last one. It takes a little bit longer to develop, though. Okay, so what happens when I have two square roots being added or subtracted? Okay, that becomes a much more difficult problem. Okay, so how about I do for you, I don't know, 71? Square root of 1 minus 2x plus square root of x plus 5 equals 4. Okay, much harder problem, actually. Okay, before doing that, little timeout. I'll box this out. Recall, if you have a plus b squared, and in case you wonder, if it looks like I'm putting that plus a little bit higher, I am. So if you want to copy what I have, that plus is meant to be a little bit higher. A squared plus 2ab plus b squared. I'm also putting that plus a little bit higher, but not that one. Okay, so a plus b squared, a plus b is a squared plus 2ab plus b squared. Okay, if you have a minus, so if you put a minus here, this one becomes a minus, so that's the reason why I raise it up. That means a minus b squared is a squared minus 2ab plus b squared. Remember that from algebra? That's a minus b is all this stuff. Okay, so that's a little sidebar. Okay, now let's tackle this problem. Okay, so I'll move this one over maybe. You don't want to square right away. It's too messy. Move one of them over and then square. Okay, so radical 1 minus 2x equals 4 minus radical x plus 5. Okay, so if you have two square roots on the same side that are being added, move one of them over. Now I'm going to square both sides. Like that. This one's nice. This one is not nice. This one's just 1 minus 2x. This one is like a minus b squared, the bottom. So I have to apply this formula. So a squared, 4 squared is 16. B squared's nice. Let me get b squared out of the way. You just remove the radical x plus 5, right? Here's a squared. The hard part for students is usually the minus 2ab. So minus 2 times that times that. 2 times 4 is 8. 8 times the radical is just a radical. Okay. So I have this mess. Okay, so one more time. I square both sides. This is nice. Square root of a square root. Just take out the square root. This one looks like a minus b squared. So I have to do a squared, 4 squared, minus 2ab. 2 times a times b. 2 times a, 2 times 4 is 8, times b, which is radical x plus 5, plus b squared. Square the radical, you just have that. Okay, so let's clean up the mess. 1 minus 2x equals, okay, let's see, 16 plus 5 is 21, plus x minus 8 radical x plus 5. Okay, so I still have this, right? Okay, throw these two over. Minus 21 minus x, minus 21 minus x. So 1 minus 21 is a negative 20 minus 3x equals negative 8 radical x plus 5. Did I do that right? Subtract an x. 1 minus, yeah, that's right. Too many negatives. Negative, negative, negative. Multiply both sides by negative 1. Negative 1 times that, plus, plus, plus. Okay, much nicer. 20 plus 3x equals 8 radical x plus 5. Much nicer. Now I square both sides again. So finally I have no more radicals. You can see there was a lot to this problem. 8 squared, 8 times 8 is 64, x plus 5. This one, I got to do this formula again. A plus b squared. A squared plus 2ab plus b squared. Okay, so here we go. 20 squared, 400, plus 2ab. 2 times that times that. 2 times 20, 40. 40 times 3x, 120x. And then my b squared, 3x squared is 9x squared. All right, so finally, I have something which has no more square roots. Still not easy. I didn't say it was easy. It's just I got rid of the square roots. Okay, let's distribute, combine, and so forth. And yeah, let me put this in order. 9x squared plus 120x plus 400 equals 64x plus 320. Oh boy. So that over. So that over. So I subtract, right? 9x squared. Okay, what's 120 minus 64? Punch it in the calculator. 56x. 400 minus 320 is 80. Okay, is that factorable? I don't know. Quadratic formula. Negative b plus or minus square root. That should be done shortly. B squared. What is 56 squared? 3136. Minus 4ac. 4 times 9 times 80. All over 2 times 9. All right, so what's underneath the square root? 3136 minus 9, oops, or 9 times 4 times 80. 256. All over 2 times 9 is 18. Square root of 256 is 16. Okay. Do the negative. Negative 56 minus 16 is negative 72. Divide that by 18 and we get negative 4 on your calculator. Do the positive. Negative 56 plus 16 is negative 40 over 18. That reduces to negative 5. Oh, no, sorry. What can I take out? Just 2. Negative 20 over 9. And they both have to be checked. So way back here, right? Let me get negative 4 out of the way. It's probably easier. 1 minus 2 times negative 4 plus square root of negative 4 plus 5. Is that equal to 4? That actually looks like it works. That's 1 plus 8, which is 9. Square root of 9 plus square root of 1 equals 4. 3 plus 1 equals 4. Okay, it checks. Okay, so I'll let you do the other check. The last thing I didn't do was to do the other check. I'll just put etc. to save time. But just plug in the other one and show that that works also. Okay, but I want to stop right there otherwise. Okay, so I'm done, folks. Let me stop share. Does anybody have a question? I don't think there was. I didn't see anything in the chat. Otherwise, I'll go straight to the quiz. And yeah, I don't see anything there. Okay, so quiz time. Okay, so get your cell phones out to take a picture, please. Go back and share the screen. All right, take a picture of this or a screenshot. Find the equation of the line passing through the points 3, negative 10, and 1130. That's it. Write your final answer in slope-intercept form. Make it look like y equals mx plus b. Okay, this is just a straight line. You're given 2 points, 3, negative 10, and 1130. Okay, so I'll give you hints. You want to find a slope, right? So find the slope of the line joining those points, and then use your point slope form. Y minus y1 equals m times x minus x1. You can look back in the book. You can talk about it, help each other out. Okay, we did lines earlier. Okay, I'll hold this up just for another 15 seconds or so. Then I'll assume everybody got it. Okay, so you're given 2 points, 3, negative 10, 1130. They form a line. Find the equation of the line. So first find the slope, y2 minus y1 divided by x2 minus x1, right? And then do your point slope form, y minus y1 equals m times x minus x1. Write the final answer in the form y equals mx plus b. Okay, I will now assume that everybody has it. Go ahead and get started, but then give me a few moments, maybe a minute to set up your breakout rooms. Okay, folks, you have an invitation to go to your breakout room. And so everybody, please join your breakout room, and you should know what to do. Okay.